All right. Again, game plan. Today we're going to continue with special right triangles. There's going to be two types. We'll continue this next class on, let's see, well, again, Tuesday. Homework from last class is due next time. And then, what's going to happen, not today, you're not going to get any new homework today. But listen up. The following class, you will get a homework assignment. The following class, I may count it as a quiz grade rather than a homework grade. So it might be just an over fancy homework, under fancy take-home quiz. All right. The due date for that following homework is still to be determined. Let's see where we go next time. Let's see what we covered today. All right. So on the bottom of the first page, we have one or two warm-up little activities. Warm-up activity number 1. Identify the hypotenuse and the two legs of this right triangle. So we're just going to do a quick identification. And one thing I'm going to say, I forgot to tell you, these notes today, that's a graded note activity. So Zoe, did you hear what I just said? What's going on with today's notes? It's going to be a graded note activity. Exactly. All right. So here we go. First one. What's the leg? Or which ones are the legs and which one is the hypotenuse?
8, 6, and hypotenuse is 10.
All right. Catherine saying hypotenuse is 10. And she said 6 and 8 were the legs. Doesn't matter how we hit the 6 and the 8. Nope, you're right, Edwin. Edwin was shaking his head. No, it don't matter how the 6 and 8 are. And you're right too, Jason. If you flipped it, I'm okay with that too. All right. Questions so far? So again, that's part 1. Now, go to the next page. You will need a calculator. The first 3 should be no problem. The last one, we haven't seen in a while. But we'll talk about that in a moment. Okay. So really quick, 20 to the second power. I am 20 to the second power. 400. 400. Okay. And then, yes, yeah, you did it exactly right, Andy. Very good. So what's this, Andy? Tell us what the second one's going to be. 75. Yup. It will be 75. Now, did anybody get the third one?
14.
So 1 squared, 400. Take the square of a square root. These guys just knock each other out. Boom, bye-bye. Just left with the 75 by itself. Square root of 196, 14. Now this last one. Here, special case. When you have 2 radicals multiplied side by side, what you do is you multiply the 2 numbers, and you can keep it under 1 radical sign. I didn't expect anybody to get this one right off the bat. This was a rule from, I want to say, Algebra 1, but I know last year was a little weird. But anytime you have a radical times another radical, just multiply the two radicals by themselves. And then, what's 5 times 10? 5 times 10.
50.
50. You got what? 7.0, what else? Okay, I know what you did. You didn't do anything wrong. You just got the decimal equivalent to the square root of 50. So, what you did was not wrong, because I know in a calculator they would have went straight to like that 7.07, okay. You didn't do wrong. So, I don't want you to think, oh, I did wrong. You didn't. They just went straight to the final decimal equivalent. But anytime you see a radical times another radical, multiply your two radicals. Okay, stop. Let's see, where are we? Sorry about that. Yeah. Okay, sorry about that. Anybody questions? Oh, hold on. Give me one. Okay, that's what I want. All right. Then sometimes they might break this down. You don't have to worry about the breakdown for now, but down the road you might have to. Like, I'll tell you when. Because in Algebra 2, maybe after they break this down, they'll break it down to like, I want to say 5. Oh, they might break this down where they'll split this into, I'm just going to write it, but this is the same. These two represent the same thing in the end. For now, just worry about this. You don't have to worry about this yet. Oh, that we will see again down the road. All right. Questions before we continue? All right. Now the next slide should be familiar. Basically, Pythagorean theorem. The longest side, crossing the right angle, you square it, it equals the square of the first leg plus the square of the second leg. So basically, this equation's true, right angle, a right triangle, and vice versa. You have a right angle, right triangle, I should say. This must be true. So these two, right triangle, a squared plus b squared equals c squared. They both work with each other. So that's basically, you have to have one to have the other, and vice versa. All right, questions? Questions about the right triangle? So that is similar to last time. All right. Now we're going to start talking about the new things. The new thing, which is the following. Special right triangles. Now, I'm going to tell you all something to make your life easier. Here is how we're going to make our lives a little easier for these types of problems. All right. for this 45, 45, 90 right triangle to work, you have to have a 90-degree angle. This is number one. Number two, at least one 45-degree angle. You only need one because if you have a 90 and a 45, that last angle has to be 45 as well. Because what do we know about the sum of the three angles in a triangle? They have to add them to 180. So if you have a 90 plus 45 plus blank equal to 180. That blank is 45. It's not going to pass go. Can't have no other number. Good morning. Okay. Don't worry. We just started. Get anything missing from. You got the notes right there? You need a pencil? All right, cool. But what I am going to say, and you know what? You might want highlighters or colored pencils or something for today. Because I want you all to take note. This is actually a proportion. Anytime use this proportion I just circled. That's the proportion I would use. So I would circle that proportion. If you have a 45, 45, 90, write it. But I'm going to tell you how to use that square root of 2 in a minute. That's the proportion you need to highlight. It's going to be one of the two. It's going to be important for the next couple of classes. Now, you're probably wondering, oh, square root of 2, I've never seen that before, right? But the square root of 2 is actually a number. Because if you type it in the calculator, okay, somebody type square root of 2 into the calculator, what do you get?
1.4141356.
Yep. See, you get a decimal number. Now, the decimal number, we don't use that often because that decimal number goes on forever and ever. It only stops on a calculator because the calculator only goes so far. But square root of 2 is a number. It's a crazy number, irrational, but it's a number. All right. So don't be as scared. Don't be too scared about that square root of 2. It's not as scary as it looks. Even though it's irrational, it's not scary. It's not as scary as it looks. Okay? Questions? All right. Here's how we're going to use this proportion. Away we go. All right. This is the first problem. Now, this is not going to be fun. Okay. Well, everybody can see the proportion on your slide, right? The bottom slide coming up. Okay. Now, first off, in this triangle, you have the 45, 45, 90 rule. You don't see it, or you may not see it well, but that's the 5. Now, is the 5 a leg or a hypotenuse? That's a leg. Now, in this case, do we need both legs or just one leg? One. Now, do we know what this other leg will be? Let's think about this. At a 45-degree angle, right? All right. Now this angle is also, say again, 45, so that means this side has to be, it's also going to be 5 again. And technically, when two angles have the same side, or they're opposite angles, let's say two congruent angles, the base angles, opposite sides are congruent. That's something to think about. We've done that before. That goes back to earlier. Remember when we had our triangles with this angle, that angle was congruent. That meant the sides going across were also congruent. Remember that from back in the day? Got the same thing going on here. Now, again, since we have a 45-45 triangle, we only needed one. We only need one of the legs. Now, for the hypotenuse, do we know what the hypotenuse is yet? It's x. So that's the most important thing. You know that this is your hypotenuse because it's across in that right angle. You see where that right angle is? Right across on the right angle is that hypotenuse. That's always in forever. All right. Now, here's how we're going to set up our proportion. Leg over hypotenuse, 1 over square root of 2. Because usually this side, you multiply by square root of 2, you're going to get a hypotenuse. So this is how we're going to do this. Leg. How long was the leg? Leg was 5. So you're going to replace in your proportion when you do your setup. Leg gets replaced with 5 equals, well, didn't do equals yet. What about hypotenuse? What did we say the hypotenuse was for now? X. Then we have, just copy this, 1 over square root of 2. Say that again. Are we going to cross multiply? You do cross multiply here. Very good. Valerie's right. You got to cross multiply because this is a proportion. You remember that from back in the day? Yeah, we do. Now, here's how we do this. Multiply diagonally. So what's 1 times x?
1.
Okay. Do we need that 1 next to the x? No.
X.
It's just x. Oops. 1x, x. Okay. Because we multiplied it 5 times the square root of 2, which, all right, that's fine. Now, what you can do, now I understand where you got the 7.07 because you multiplied 5 times 0.2. So it's about, let me use a better one. Hold on, one second. Right, the final numerical answer, if you multiply 5 times square root of 2, would be that 7.07. And then the number goes on forever. But I'm going to leave you some space because here's what I'm going to allow you to do. with that 5 times square root of 2, you can, I'm going to let you leave it as 5 times square root of 2. Okay. You are allowed to leave your answer as 5 times square root of 2. So I'm not gonna, so if you did not go beyond here, that's okay, because whole number times non-perfect square root, you can leave it like this, 5 square root of 2. I will allow it. You do not have to make it 7.0. If you did leave it as 7.07, Valerie, it's not wrong. But if you left it as 5 times square root of 2, I'll accept it. So I just want everybody, this is more clarification than anything else. All right. Anybody have any questions for me before we go on? But yeah, anytime you multiply a whole number or an integer by a radical number, if you leave it as whole number times that radical, you can leave it like that. You're not gonna get, I'm not gonna penalize you. Okay? Questions? All right. Let's look at the next one. Okay, this one's gonna be a little different. This one might be a little more involved, but not by much. All right. Now, who could tell us what's going to happen here? All right. So we have x is the leg. Now hypotenuse 10. So we had, somebody said x over 10, 1 over square root of 2. Okay. All right, that's fine. Now, what do we do next? You do cross multiply. So 10 times 1 equals. Now, here's how I'm going to write this. Here is how I'm going to write this. It's going to be a little different than normal. I'm going to leave it as x times square root of 2. All right. Now, here is where things can get a little crazy. So, well, what's 10 times 1? 10. This is where we're going to need a little more work. Now, you see, we have 10 equals x times square root of 2. All right. Here is where we could see a problem. Normally we see multiplication. What's the opposite of multiplication? Division. All right. Okay. Well, be careful. Is that 10, is that 2 or is that square root of 2? Okay, that's a good question. Do we square 10? The only reason why we're not going to square the 10 is because then you have an x squared. Because if you square this side, you have to square that side too. What we are going to do is the following. What could I do? Does anybody remember from last class? What could I do to get rid of that radical sign? Anybody remember? Okay. So that could happen. So you're on the right track. Yeah, if you did this, you're right. That's going to get rid of it. However, if we wrote this out, well, almost. Rather than 2 times 2, it would first be actually be square root of 2 times square root of 2. But in the end, as you said, what happens with the square root and the exponent? Right, that would go away. It would just be 2. So what you could do to get rid of the radical sign, anytime you see the x with a radical sign, you can multiply it by square root of 2. But you have to do it on both sides. Yes, indeed, Des. Very good. You do that there, you got to do that here too. In fact, I'm going to switch this up slightly. You'll see why in a second I'm doing this the way I'm doing this. Yes, if you multiply the square root of 2 this side, you have to do it over here as well. Very good. Now, 10 times square root of 2. Can we do anything with it for now? No, leave it alone. However, when we multiply the square root of 2 by the second square root of 2, what does that really become? This just becomes a plain old 2. So you kind of have x times 2. But what's really x times 2? 2x. So x times 2 is really 2 times x. All right, we're going to get to the x part in a second. So we just switched the 2 and the x. But are we finished with this problem? Divide by 2. You got to divide by 2. That's your last step. Now, we do have the x by itself. Now, the square root of 2, we can't do anything with it. Well, can we divide 10 by 2? Is 10 divided by 2 allowed? Can you divide those two numbers? Yeah, you can. So what's 10 divided by 2? 5. That's going to be your value of x. So I think the most complicated part of this type of problem is going from here to here. The way you can, because in the end, we really don't want to have radical numbers multiplied by x. You really don't want that. But the way to get rid of it is to multiply both sides by that square root of 2. That's the quickest way to knock it out. Because you don't, like proportion-wise, you can set it up this way, but like if you just want a regular number, you really don't want a radical in the negative. I mean, that, you really don't want the radical in the denominator. Let me rephrase, sorry about that. This is the key step right here. Now, again, the way to get rid of that radical, multiply by itself. However, if you have a whole number times a radical, you can leave it in this form. That's not wrong. All right, any questions? I'll give you all a minute to process this information. This is going to be the new concept. I know we haven't seen this in a long, long time. Maybe this might be the first time you've ever seen this too. But that's the most important step. All right, good morning. Okay. Give y'all a minute to process this. Any questions? Yeah, I think all of these problems we're going to be doing together. And again, it's not a knock on anybody. It's just more I want everybody to see. When we set up our proportions, it's what we do to solve, and especially with these radicals, because the radicals we haven't seen in a long time, maybe ever. So you have to be patient. Okay? Questions before we continue? All right. Look at the next one. Okay, this one might not be so bad. All right, so what's our leg? What's our hypotenuse? Leg is 8. The hypotenuse is x. So how are we going to set up our proportion? What's going over what? 8 over x. Very good. Equals 1 over square root 2. Now, like before, what's our step we have to complete? Cross multiply. One times x or x, you're right. Equals. That's it. You hit it. Now, do we have to do anything else? In this case, we don't have to. Because the x is by itself. The square root of 2 is part of that overall number, 8 times square root of 2. So you don't have to do that times square root of 2 business. You don't have to do that here. What's that? Say it again. I cannot hear what you're...
He's asking, how did we get rid of the 1?
Because what's 1 times anything?
It's by itself.
It's by itself, because 1 times x is just x. If it's a 2, then we have to, if it was 2 times x, then we have to divide. Okay, now I know what you're asking. But yeah, since this is 1 times x is just x. You don't have to do anything. So this problem is actually finished. You don't have to deal with that multiply by square root of 2 business because you don't have an x there. So this one's already done. So some of these, yeah. You don't have that x with the square root of 2 or whatever square root. You're done. You don't have to do anything. All right, questions before we go to the next one? Because, yeah, some of these are just going to be quick knockout. You're done. But some of them are going to be a little more. All right. Are we ready for the next one? Good? Good? Everybody over here, we're good as well? All right. This one's going to be interesting. Well, what's our leg? What's our hypotenuse?
Hypotenuse will be 3 the square root of 2.
3 square root of 2 is your hypotenuse. And then what's the leg?
X.
Right. Let's see what we have here.
Will be x over 3 square root of 2.
Mm-hmm.
Then the other side will be 1 over the square root of 2.
Okay. This one's going to get interesting. Now, as usual, what do we need to do?
Cross multiply.
Cross multiply. So, well, what's 1 times 3 square root of 2? It's just going to be 3 square root of 2. Then you have x times square root of 2. All right. Now, this is where we're going to do times square root of 2. Okay, I should have done this. We'll move that over here for now. You'll know why. So, Des, you said, why are we going to multiply both sides by the square root of 2 this time? Okay, we can't subtract because, remember, you're multiplying here. And here, there's no adding or subtracting, so there's no subtraction. Okay, you're on the right track, so we get the x by itself, but more importantly, when you said again, multiply both sides by what again? Square root of 2. Okay. Let's see where we're going with this. All right. Probably wondering, how did Des get 6 equals 2x? Here's what happened, ladies and gentlemen. All right. In fact, here's what I'm going to do. I'm going to put this step down here. The reason is I want everybody to see this step by step. So right now, do your cross multiplying. 3 times square root of 2 is just 3 times square root of 2. Now we're going to multiply by the square root of 2. Similarly, x times square root of 2, x times square root of 2. Then we multiply both sides by square root of 2. Well, what happens when we multiply this square root of 2 by that square root of 2? What do we? It's 2. Good. So for right now, we have 3 times 2 equals, which is 6. That's right. Over here, same thing. Square root of 2 times another square root of 2. X times 2, or 2x. Very good. That's exactly. Very good. That's exactly how we knocked this one out. Well done. So x in the end is going to be 3. So the leg will be 3.
Well, you know, the answer was in the problem. Okay.
Well, almost. But the most important thing was, when do we multiply both sides by that square root of 2? You do that when you see the x. When the square root of 2 is, when you do your cross multiplication, if you see x times square root of 2 or x times square root of something, you better multiply both sides by that square root of whatever. Because the goal is, you really should not, in the end, I know this is a bad example, being you have your square root in the denominator, but when we deal with square roots, like numbers and square roots, you really don't want the square root or radical in the denominator. You really don't want that in the end. All right. But this is the most important step right here. You see x times square root of 2, you better multiply both sides by square root of 2. All right, questions? Then you're going to see something like that on the next problem as well. I will show you. All right, any questions before we go to the next problem? Okay, all right, get this down. Make sure you get this down. Because we're going to be doing something exactly like this. In a minute, you're going to get basically the same type of problem. If you want to try that last one, the one that's on the bottom, go ahead. You want to start trying it. Because the last one, if you look at number 5, I'll put it on the board momentarily, but if you look at problem 5, what's given to you? Hypotenuse is 18, and the leg is?
X.
All right, so there's your first step. Label. And then, are you able to set up your proportion?
Yeah.
Okay, you can do that. I'll keep it over here. We said leg, X, hypotenuse 18, 18. And then I'm going to set up our proportion. What's on top, what's on the bottom?
X over 18 and 1 over the square root of 2.
All right. Now, just like before, what do we need to do? Cross multiply. It's a crisscross applesauce deal. Of course, what's 1 times 18? 18. And then what's x times square root of 2? Well, do we do anything with this thing now? Not yet. All right, good. Now, what should we do next? I have an x times square root of 2. Here's what we do this times square root of 2 on both sides, everybody. Anytime it's x times square root of whatever, that's when we do this. Multiply by square root of 2 here. Multiply by square root of 2 here. Now, for the moment, is anything going to happen here? No. Which is 18 square root of 2. It's 2x. Very good. Because square root of 2 times square root of 2 is just 2. So you would have x times 2, or 2 times x, or 2x. That's the most important part right here. You have this, you see this, you have to do that. Get rid of that radical next to the x, and then what's our last step here? Divide both sides by 2. Then rather than 9 what? Well, 18 divided by 2 is 9. But does that square root of 2 go away? No, you got to keep that square root of 2. This works here. This guy you have to drop. I can keep that square root of 2 with that 9.
So that's right.
That's going to be your final answer. Bless you. There's your value of x. 9 times square root of 2. All right, any questions so far? Now, we're going to be doing similar stuff the rest of the way, but we're going to be dealing with different type of triangle. And that's called the 30, 60, 90 triangle. And for these types of problems, you're going to have to do now 1, maybe 2 proportions per problem. If you can do this, you can do that too. The question is just a matter of which proportion or proportions you need. It's all about what's given to you. And that's why I say label, label, label. We agree? Label, 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 very important. All right, so that's what we're going to be doing the whole time. Portion, setup, solve. So some of them it's just going to be 1 proportion. Some of them might be 2, depending on what's given to you. But it don't matter. All right. Also, we're going to probably see this rule again. Maybe not so much with square root of 2, but maybe square root of 3. All right, basically, 30, 60, 90. Well, I should say 1, we should say 1 or 2. 2 of the following ratios we'll have. All depends on the type of problem. You might want, it's going to be one of these 3, I guess. Well, they didn't show up too well. Oops. Yeah, this did not show up as well. You're going to have one of, maybe 2 of the 3 following ratios, depending on the problem that's given to you. Don't worry so much about this. The only thing I ask you to worry more, identify. Identify. You have to know which one of these 3, or which 2 of the 3 you need to find, given the 1 or 2 that you have. Again, identifying, identifying, identifying. That's the key. And we're going to be doing that throughout the whole time. So any questions before we get started? We can do square root, we can do 45, 45, 90. You can do 30, 60, 90 as well. All right, here we go. Ready? Okay. Now, we say find the value of missing side or sides. Given this triangle, the short leg is 8. That's always going to be opposite. That's always going to be opposite of the 30-degree angle. Now, this is all. So you see 30, look across, boom, there's your short leg. Now with the 60-degree angle, that's going to be opposite long leg. Now, do we know what the long leg is yet?
Yeah.
No. So what can we identify for the long leg for now? X. Do that, put that as an X. Or you could leave it LL. If you want to do it that way, that's fine too. I don't have a problem with either one. However, which one has to be the hypotenuse? Where are hypotenuse? So it's across from the 90-degree angle. Now, we don't know what the hypotenuse is yet. But if we assign it a variable, do we want to assign it X? Well, here's the only problem. We already have an X. So, are we just limited to X? Mm-mm. You don't have to always use X. If you want, I got a couple options. Hypotenuse begins with H, right? Can we say H for the hypotenuse? You can do that. There you go.
So we just like use any other variable.
Yeah. That's right. Any other variable. If you use X, you can't use it twice.
So any other variable except X.
If you've used X already. Now, if you said this was L, and then made the hypotenuse X, that's okay, but you just can't use the same variable twice. So that's the thing. Now, for these types of problems, we're going to be doing two proportions. So now we need to figure out which two proportions we're going to use. Here's how you do it. With our proportions, what do we already know? Which one out of the three that's given to us? What one do we know? What has the actual number? The short leg, which is 8. And I tell everybody, mark it. And then the reason why I tell you to mark it is because, well, the long leg we don't know. But the long leg we know is X. Now, do we know the hypotenuse? No. Don't know the hypotenuse. Now, out of the three, I apologize, this did not come out too well. Which is the one proportion we don't want to use at all? You have three options. Option one, option left, middle, right. Which one do we not want to use at all? This one. Yeah, you don't want to use that because we have how many unknowns? So, bang, you see two unknowns. Don't use it. Can we use the other two? That's right. Here, you have 8 over X equals 1 times square root of 3. That's for this one. And in this one, you have 8 over H equals 1 over 2. Let me fix that a little. can we solve for these two proportions? You can. You can solve for both of these proportions, actually. All right. Well, in the first case, do our cross multiplication. What's 1 times x?
1 times x,
X. What's 8 times square root of 3? Well, do we have to really do anything to the 8 times square root of 3?
No.
No. Quite a few of you said no, we can leave it. Is there anything else we need to do?
No, that's it.
That's it. Same thing over here. What's 8 times 2? H is going to be 16. 1 times H. H. 16. Now we have everything we need. We have everything. We have a hypotenuse. 16. Boom. We have a long leg. 8 square root of 3. There we go. We're done. Yeah. Yeah. Take the agenda. Take your agenda. All right, questions on that one? That's basically all we're doing. Once you set up your proportion, this is the hard part, getting from here to there. But if you get from here to there, then it's real easy. And we just saw that, right? We're like, oh my goodness, we have to find 2 variables, right? How long did it take us?
About like a minute.
That's it. Now I know some of them might be a little harder because especially when we're dealing with them, we have to deal with that radical. But that's only going to take an extra minute, right? Maybe 2 at most. But again, the most important part is identifying what you have and figure out which proportions you will use. And the goal is, again, label everything. And if you see the proportion that has more than 1 variable, do not use the proportion with more than 1 variable. Valerie, you agree with me? So, which proportion do we not use? Say it again. Well, which one? Because I don't know what the X is. I don't know what the H is. Because how many variables were there? How many variables do we see here? How many? X and H. Is that 1 or 2 variables? 2. There you go. All right. Let's have a look at what we have over here. Okay, in this case, what's given to us? What do we know right off the bat?
The hypotenuse is 22.
All right, that's a good start, Jason. Hypotenuse, 26 centimeters. Okay, now. Okay. So do we know what the short leg is yet?
No.
So what can we do from there?
We could mark it as X.
Mark it as an X. So the short leg, you were right there, it's crossing the 30. And as Jason said, mark it as an X. Good. Now where's our long leg? Where's the long leg? Here's our short leg. Where's our long leg located? Say again? Okay. Technically, you're right. It's crossing the 60. So below the 30, yeah. You're kind of, yeah. Okay. We don't have a number, but what can we do?
Mark it as another variable.
Mark it as another variable. All right.
Let's mark it as A.
As a what?
We can mark it as an A for now.
Sure. Okay. I'm okay with that. Yeah, you can mark it as an A. That's fine. All right, now, let's figure out what we can and cannot use. So, short leg. What was the short leg?
X.
X. Here. Here. Long leg.
A.
Here. Here.
And the hypotenuse is 26.
26. 26. Now, which one do we not want to use? Why? Oh, I don't. Do I have how many variables here? You're right, Valerie. We're not using the first one because how many variables do we have here?
2. They filled it up.
Boom, 2. You don't want that one. But can we get the X or the A using these other two?
Yep.
Yes. Here we go. How are we going to set up our first one? What over what?
X over 26.
Uh-huh.
And 1 over 2.
1 over 2. Very good. So there's your first one. Boom. That one's very easy.
The other one is A over 26.
Okay?
The other side would be square root of 3 over 2.
Okay. Now, in both cases, can we solve for a variable? Can we solve for a variable in both cases?
Mm-hmm.
Yeah. That one's going to be real easy. Do your diagonals. Basically, what's 1 times 26? 26 times 1, 26. What's x times 2? X times 2, 2x. Well, we can solve for x. That's real simple. X is going to be 13. That one. Okay, 13 is x. So we have an x value. Okay, what else do we need to find?
Leg.
All right. I'm just going to make the nose of the 3 a little bit smaller. All right, now we need to find the A. So x is done. So x was what? What was the,
X was 13.
which represented the
Short leg.
short leg, right? All right, now, let's get this one. Like before. This one's not gonna, this one is not too bad either. Because 26 times square root of 3, can we do anything to that? No, that's gonna be left alone. But what about 8 times 2? 8 times 2 is 2a. Now we divide by 2. Okay, hold on, one at a time. Go ahead, you're right. Keep going, keep going. Yep, because just divide the two numbers, 26 divided by 2. You get 13, square root of 3. And then what happens with the 2a over 2?
Just eliminates itself.
It's left with a. Okay, somebody had a question earlier about, oh, look, Make that look- Oh, I know what happened.
Hmm.
I know why somebody thought that was 18. That A looked like a 9. That's my fault.
Oh, yeah.
My fault. Okay. That was your question, right? Okay. That was my fault. So then the 13 square root of 3, that's our,
Final answer.
for the
For the long leg.
long leg. Yes. Long leg. Good. Because going forward, we need to figure out what do these answers represent. Okay, questions? These aren't too bad, right? Once we start working, once we figure out what's what, we can knock these proportions out, yeah? Pretty easy. All right. Questions before we go to the next problem? All right. See what we have going on for the next one. All right. Let's figure out who's what.
Alright, so what I see is that hypotenuse is X,
All right, that's a good start.
then our short leg would be Y,
Short leg is Y. Very good.
and long leg would be 6 with the square root of 3.
Excellent. Excellent. All right, that's a real good start. Short leg. Long leg. All right. Good start. All right, so now, what proportions are we going to use? First one and the last one, very good. Can't use the middle, because that's a Y and an X, so out of the game. Boom. Let's not use that one. Cross it out. How are we going to set up our first proportion? What's over what?
Short leg.
Which,
So it would be Y over 6 with the square root of 3
good, equals,
equals 1 over the square root of 3.
yes. All right. Now here we go. Go across. Now I'm going to show you a trick to make your life a little easier with this type of problem. You don't have to use it, but you can. Okay, what's Y times square root of 3?
Y with the square root of 3.
Okay. And then 6 square root of 3. Well, what's 1 times 6 square root of 3? Okay. Now, do we really need the 1 for the moment? No. Okay, you can do that. All right, that's fine. I'm not going to say no to that one. So you can do it that way. I'm okay with that. So does everybody understand why Des is going to multiply both sides by the square root of 3? Because what's our goal? We want to get rid of the radical, right? Okay? Because really, what's going to happen here? And what's going to happen here?
They're just going to convert themselves to 3.
We're going to become a 3. So really, you have 6 times 3 equals Y times 3. Now, Well, of course, what's 6 times 3? 18. 18 equals, what's 3 times y, or y times 3? 3y. And then, can we solve for y?
Yes.
Yup. Divide both sides by 3. Y is
6.
Okay. That's the first one. Y is 6. Y is 6, so that is our what leg?
Short leg.
Short leg. Now, the next one, I'm going to show you something that's going to make our lives easier. Well, actually, all right, I'm going to show you a step for this problem. So when we set up our second proportion, well, how are we going to set up our second proportion?
It would be 6 with the square root of 3 above.
Okay.
Now, our continuous would be x at the bottom.
Uh-huh. Equals.
Equals the square root of 3 over 2.
Okay. Now, I'm going to show you something about a second, which might make your lives very easy. Of course, what do we always do? What's first? What do we have to do with the proportion? We cross multiply. So right now, you have x times square root of 3 equals, well, when we multiply 2 times 6 times square root of 3, well, what's 2 times 6? Who can tell us what's 2 times 6? Well, okay. X times square root of 3 equals 12 times square root of 3. Now, this might be the one time where I'm going to tell you, you may not have to do this multiplied by 3 business, square root of 3 business. Here is why. Take your calculators. Type in square root of 3. Then type in the division symbol. And then type in square root of 3 again. What happens?
3 divided by 2 over 3.
Yeah. What do you get?
Decimal.
Square root of 3 divided by square root of 3? Try it again. You get 1. You got spacing. But whenever you divide, even with a square root, since both sides are being multiplied by 3, or square root of 3, I'm sorry, you can divide both sides by square root of 3. Because similar to a whole number, the only reason why you can get away with it here is because notice how both sides have that multiplied by square root of 3. We see that there? You can get away with dividing both sides by square root of 3. Since both sides are being multiplied by square root of 3, you can divide both sides by the square root of 3. You can get rid of it. And then, as a result, what would be our value of x? What's the value of x then? 12. Because this is going to be the one time. But notice how we had both square root of 3, square root of 3. could we have done it over here too? You could have. Because both 6 times square root of 3, y times square root of 3. You could divide both sides by square root of 3. Now, in the end, both ways work. I just want everybody to see both ways. So you can save some time. If you see that both sides are being multiplied by the same square root value, you can divide by that square root value and just you save yourself some time.
So we just solved for the hypotenuse.
Yep, we just solved for that hypotenuse, which is 12. Okay, questions? All right, here's what we're going to do with the last two. Because I know time is not our friend right now. But what I am impressed is how we're setting up our proportions. You guys are doing a great job. So here's what we're going to do for the last two. All I'm going to ask is the following. For this slide, how are we going to identify what's what? Who can tell us what's what in this triangle?
I see the hypotenuse will be y.
Y is the hypotenuse. All right. Short leg. Hypotenuse. Long leg. Now, which two are we going to use? Which two out of the three?
The second.
First one and the last one, because you had a 15 here. You have a 15 here. You can use them two. Short leg X. The hypotenuse will make it Y. You have X over 15 equals 1 over square root of 3. Now, this would be the one where, yeah, you do your diagonals. 1 times 15 equals X times square root of 3. Now, this is one where you can't just divide by square root of 3. Because do we see a square root of 3 over here?
No.
This is where we have to go back and do our multiplying by like square root of 3, all that fun stuff. I'm going to give you the answer, though. I will give you the answer to that one. Because when you do that, in the end, you're going to get, I'll have you try this. You should get 5 times square root of 3 is X. I'm going to leave some space, but you can try that. Let me see. Yeah, because you multiply both sides by the square root of 3, but then you're going to divide this big guy by 3. So I'll let you look at that. You can fill in those steps. I'll give it to you. Here, similar situation. We are understanding how to get from 15 over y square root of 3 over 2. Similarly, you're going to get y times square root of 3 equals 15 times 2. Well, what's 15 times 2? What's 15 times 2, ladies and gentlemen? Do we know? Is that a whole number, 15 times 2? What do we get? You get 30. Now, just like before, Yeah, we have to multiply by the square root of 3. And yeah, you get 3y equals 30 times square root of 3. But then we divide both sides by what number?
3.
3. So then your y would be 10 square root of 3. So I'll give you those. These real quick. What happened?
I'm thinking of something else.
Okay.
I'm trying to figure out my.
So,
Sure. Go ahead.
so we just crossed out the second proportion.
Yeah, you gotta cross this guy out because you got a double variable. You had the x and the y. You don't want that. So the good news is most of us understood what was happening. I'm just gonna write it out real quick. All right. Then the last one. I'll just give you all the last one real quick. Oh, you know what? The last one is just like this one. Because here's what happens. Don't worry about the last problem. Here's why. What's the short leg for this problem?
5 with the square root of 3.
And then long leg was 10 square root of 3. Well, guess what? In the last problem, what's our short leg? What's our short leg for the very last problem?
5 with the square root of 3.
So basically, this is the exact same problem as the last one.
You just flipped it.
And it was my fault because when I was going through the notes, I realized, wait a minute, one of these problems repeated.
Except the triangle was upside down.
Right. So basically, long leg and a hypotenuse, long leg and a hypotenuse are going to be the same. So whatever you had here, copy. 15, 10, square root of 3. Those two problems are exactly the same. So basically, from 9, copy, 10. You got it. All right. I'm just going to do a real quick scan of who did what. It looks like, sorry. Yeah. Yeah, that is the end. Yep, you're right. Okay, I think we're looking. All right, so I'll make sure everybody who was here, you will all get credit for this notes activity. Oh, gracias, señor. Oh. Ven. Pues yo también. Oh, ahí está. Chévere. Gracias. Gracias, Alex. Okay, everybody. Don't have any homework this weekend. And next class, we're going to resume this concept, resume this activity. All right. Enjoy your weekend. Yep, thank you all.